All right, number 11. What section is this on?
1.4.
1.4. Okay. Foundations of Math 20, 1.4. This is number 11. Great question for us to look at. Let me read it. Cleo noticed that whenever she determined, now listen, some of you, again, with this language stuff, you might not know what determined is. If you don't know what determined means, you need to look it up, okay? Or you need to ask during class or after class or when you're doing your homework. Mr. Maxwell, what does determined mean? Is this like some calculus word? No, determined. She figured out, okay? Determined. She found out or figured out. That's what determined means. The difference, difference in math, a difference is subtraction. Between the squares, oh my goodness, what squares? Squares is when you multiply a number by itself. It's squared with the 2 as an exponent, okay? So some of you in this chapter, I realize it's difficult, but you need to start doing this, and you need to put down your words and define them and draw pictures and learn and study and increase your vocabulary. All right, consecutive, another one. Consecutive. Somebody asked me about that yesterday. Great job. One right after the other without skipping any one. Okay? So if we're talking about consecutive even numbers, we're talking about an even number and then the very next even number. You don't skip an even number. So it's like 2 and then 4. Or 10 and then 12 is the next consecutive even number. Okay? Yeah. The screen's black. Well, that's unfortunate for you, isn't it? I'm having a good time here. There you go. Thanks for finally letting me know. Okay. Apologize for that. It seems we just got finished our quiz. Okay. So even numbers are evenly divisible by 2, right? We talked about that yesterday. So an even number is in the form of 2n, or 2 times some number. 2 is a factor. So 2 is a factor. That's what makes it an even number. 2 is a factor. Okay. So the difference between the squares of consecutive odd numbers, so consecutive even numbers or consecutive odd numbers, the result is a multiple of 4. Show inductively that this pattern exists. So inductively, that's the first type of reasoning where we consider examples to verify the statement. And then prove deductively. So proving in math, we're using variables as representations for these numbers, and we're showing in a general sense that this is true for all possible numbers in the set. So that's how we prove with variables and representations deductively. So we take, is this a rule? I'm going to see if I can prove it for all examples. So you're going down. Okay, so this is good. This is good. There's a lot of good stuff in here, a lot of important stuff. So some examples. Okay, let's take some examples. Consecutive even numbers. I'm going to go 2 squared, and then it's a difference. Oh, okay. Well, if we're going to take a difference, probably a good idea. Oh, we could do the bigger one first or the smaller one first, I suppose. It just says 2 consecutive. So the difference of 2 consecutive. Let's try this. Usually, if you have a choice, we're going to take the large number, subtract the smaller number. Then we're going to be dealing with positive answers, but that's okay. So what is this? This is 4 minus 16. So that's going to be negative 12. Now, is negative 12, as an example, is that a multiple of 4?
Yeah.
It is, because negative 12 could be written as 4 times negative 3. So there you go. 4 is a factor. So it is a multiple of 4. Check. This one checks out. Does everyone see how that first example checks out?
Yeah.
Okay, let's do another one. Let's do 12 squared minus 10 squared. Let's go the other way around. So consecutive evens. That's 144 minus 100 equals 44. Can 4 be written as a product of 4 times some integer? Sure can. 4 times 11, right? So there you go. 4 is a factor, therefore it is a multiple of 4. Now it says odd ones too. Let's do one more. That's the second example. One more example. 3 squared minus 1 squared. Okay, that's going to be 9 minus 1 is 8. 8 is 4 times 2. 4 is a factor. It is a multiple of 4. All 3 of our examples work. So that is inductively showing that the pattern is valid. We okay with that?
Yeah.
All right. Question?
Yeah. So how much examples do we need?
How many examples? Good question. If you do a few, that's fine. Like 3 to 5, whatever, that's good. If you do 1 example, not enough. 2 examples, okay. 3 better. Yeah. So 3 examples would be fine. 1 is not enough to prove a pattern. 2, you might have made a mistake with 1 and got a false positive. So 3, generally, you're pretty sure now that if 3 line up, you're okay. Okay, now prove deductively. Okay, so here is the big part of 1.4 here, integer proofs. So what I'm going to do now is I'm going to now represent a number as x, okay? I'm just any number. And it can be even or odd, so it doesn't really matter. You could do 2x to be an even number. You could do 2x plus 1 to be an odd number. But you don't have to. You could just go x. I might do those other examples later if you did that. But x is your first number, and we're going to go squared, okay? Now I'm going to go subtract what would be a representation using x of the next consecutive even number, if it is even.
X plus 2.
Okay, not 2x,
X plus 2.
but x plus 2. Or the next consecutive one lower, less, is x minus 2. Okay, either one. So I'm going to do x plus 2. Okay, so once again, this is a given number. This is the next consecutive, either even if it's even or odd if it's an odd number. So this is the next one. Okay, so let's now see if we can use these representations to make a statement about all x's. Okay, so this is going to be x squared minus, now be careful when you subtract what's going to be multiple numbers of terms. I would suggest you use brackets to keep these separate for now. This is going to be x squared plus 4x plus 4. Now, just an aside, if you're unsure about that, this is x plus 2 times x plus 2. That's what x plus 2 squared is. Do the FOIL method. X squared plus 2x plus 2x plus 4. Do you remember this?
Yeah.
So that's where you get this. Okay? Now, I did this in my head. You might not be there yet. You might have to write this out and show your work. God bless you if you have to do that. No problem. Just don't make a mistake. Don't do it in your head if you're unsure. If you're unsure, write it out. So, yeah, that's fine. Okay? Use the paper that you've purchased here. Use the paper God gave you. Okay? Right on. He grew trees so you could have paper so you could do math. That's the sole purpose of trees. No, I'm just kidding. It could be. I don't know. But one of the purposes. One of the purposes for sure. For sure. But yeah, so show your work. Take an extra 5.7 seconds to do that so you get it right. No problem. Okay. Having said that, I got to make sure my work is right. Okay, good. Now, if I simplify this, guess what? X squared minus x squared. Those are gone. Then I have minus a positive 4x. Then I have minus positive 4. Do you see how this negative distributes to everything inside those brackets?
Yeah.
And for those of you that are still unsure, let me just rewrite the intermediate step. See that? That's what happens when you subtract all of those terms at once. To get rid of the brackets, you can just apply that negative sign to all the terms. So this becomes negative 4x minus 4. Oh, this is really good. This is really good. You know why? Because I can take a 4 out of here, and I'm left with negative x minus 1. Yes, you can take a negative 4 out, but we just want to identify that this result is a factor of 4, or has a factor of 4, or is a multiple of 4. So this proves that the result, whatever it would be, would have a factor of 4. Okay, so this kind of showing your work process, perfect. Now, really quickly over here, if you want to say, oh, Mr. Maxwell, I don't like the whole x thing. I want to do, an even. So even, so here's an even, and here is the next even number. It's going to be 2x plus 2 squared. Okay. Now, do you want to put like equals 4 times something? I wouldn't. I would just examine this expression and show that it has a factor of 4. So I'd be careful with putting equals something, because you know what I mean? Because you'd be tempted to move stuff from one side of the equal sign to the other. It's not really an equation like that. What you're doing is you're proving that this expression has a factor of 4 or is a multiple of 4. You're not really manipulating an equation. Now that might not make sense to you, but when you get to, what is this, Foundations 20? When you get to Pre-Cal 30, we're going to spend a lot of time on proving identities, where you have to be very careful to just change this expression without actually involving what it's supposed to be shown to be equal to. So this would be a case where I wouldn't put an equal sign. I would just show what this expression really is. And so this is going to be 4x squared. This is going to be minus 4x squared minus 8x plus 4.
Plus 8x.
Plus 8x, thank you, plus 4. Yeah, I was I was doing the negatives at once. That's okay, I'll show this other step. So minus 4x squared minus 8x minus 4. So we've got this goes with that. They cancel each other out. We have negative 8x minus 4. I can pull a 4 as a factor out of there. Negative x minus 1.
Minus 2x.
Sorry, 4, this is minus, yeah. This is negative 2x minus 1. So 4 is the factor. Good.
Wait,
Okay.
Can we
Can you flip it around? Yeah, you can do 2x plus 2 squared minus 2x squared. And then you wouldn't have the negatives in here. These would be positive. Okay, so does that help with 11? There's a lot of stuff in there, but is that good? Yeah. Anybody have any related questions with number 11? So this just gives a typical number and the next either even or odd, whichever the first number is. This is specifically for even numbers because I started with a 2x. Yes?
I was going to ask, because you said we need at least 3 examples. Is that for each of the things she knows?
Right, yes, that's 24.
That's right.